Greeting. Peace be with you. In this video, I am going to do an experiment on color sensor with Arduino Nano development board. DumbDisplay will be used as UI for the experiment. To connect to DumbDisplay Android app, Bluetooth connectivity is used. Before showing the connections, I will first discuss a little bit about the color sensor itself. The TCS3200 color sensor used in this experiment has a total of 16 light sensing cells arranged as a 4x4 matrix. Each cell has 4 filters on top, namely, red, green, blue and clear, that is no filter. The filters help to focus on which one of the 3 primary color to sense. For example, with the red filter, the intensity of the primary color red can be sensed. Indeed, the color sensor can be used to sense red, green, blue individually. To control which color to sense, the 2 input pins S2 and S3 are used. Inside the color sensor is logic to turn the sensed light intensity as pulses, output to the output pin of the color sensor. The pulse width is proportional to the light intensity. Hence, by measuring the pulse width, the intensity sensed can be read. There are 4 presets of scalings of the pulse frequency. The 4 presets are controlled by 2 input pins S0 and S1. They are 100%, 20%, 2% and 0%, that is disabled. In this experiment, the preset 20% is used. Next, let's see the connection diagram. For Bluetooth module HC05 or HC06, connect VCC to 5 volt of Nano. Connect GND to a ground pin of Nano. Connect TXD to D2 of Nano. Connect RXD to D3 of Nano. For color sensor connections, connect VCC to 3.3 volt of Nano. Connect GND to a ground pin of Nano. Connect S0 to also 3.3 volt of Nano. Connect S1 to a ground pin of Nano. Connect S2 to D8 of Nano. Connect S3 to D9 of Nano. Connect out to A1 of Nano. Now, let's review the sketch. The sketch will by default assume HC05 or HC06 Bluetooth connectivity. If this is not the case, please comment out the macro Bluetooth defined by line 5. But then, you will need DumbDisplay Wi-Fi bridge to connect to DumbDisplay Android app. Lines 7 to 13 declare the DumbDisplay object. Depending on whether the macro Bluetooth is defined, the DumbDisplay object is declared a bit differently. With Bluetooth, DD software serial I/O is created and passed in as I/O object. If without Bluetooth, the basic I/O object is created and passed in. Lines 17 to 19 define the pins to use. Lines 23 to 32 declare some DD layer objects to be used for the UI. Those DD layer objects will be created and set up in the setup block. Lines 35 to 43 declare the routine get RGB intensity to read red, blue, or green color intensity from the color sensor. It uses S2 and S3 to control which of the red, blue, or green to read, then it uses the Arduino routine, pulse in, to read the pulse width of the output pin of the color sensor. Lines 45 to 58 declare 3 routines, one for reading red color intensity, one for green and one for blue. They simply rely on get RBG intensity routine to do the actual work. Lines 60 to 66 declare the routine to RGB to convert red, green or blue color intensity in the corresponding RGB color value, as used by computer, which ranges from 0 to 255. Note that the higher the color intensity, the lower the color value will be. Lines 70 and 71 declare 2 global variables, calibrate min and calibrate max. These 2 variables are used to signal the current color is appropriate for setting min or max of the red, green and blue color intensities. When the color is white, the color intensities for red, green and blue are the minimum. When the color is black, the color intensities for red, green and blue are the maximum. Line 74 to 82 declare the DumbDisplay feedback handler that intercepts clicking on the DumbDisplay UI. When the white button is clicked, it signals to calibrate the minimum of the red, green and blue color intensities. Similarly, when the black button is clicked, it signals to calibrate the maximum. In the setup block, line 86 sets the serial baud rate to 115,200. As a result, when open serial terminal, remember to set to this baud rate to match. Lines 88 to 90 set the pins mode of the different pins defined previously. Line 92 sets the background color of the DumbDisplay. Line 94 to 96 create and set up a plotter layer, so as to show the red, green, blue intensity values, as charts, on the plotter layer. Lines 98 to 103 create and set up the RB and GLED layers, which are supposed for showing the darkness of the corresponding RG and B color values. Lines 105 to 113 create and set up the RB and G 7-segment layers. These 7-segment layers are supposed to show the RB and G color values in hex form. Lines 115 to 126 create and set up the white, black and color LCD layers. The white and black layers are used as button to calibrate the minimum and maximum of the color intensities. To calibrate, shine white to the color sensor, then click the white button. Afterward, shine back to the color sensor, then click the black button. The color LCD layer is used to show the actual color detected by the sketch. Lines 128 and 129 set the feedback handler to the white and black layers. Lines 131 to 144 call the auto pin method of the DumbDisplay object, laying out the different layers in the desired way. This concludes the setup block. Before the loop block, lines 148 to 153 declare the variables for the minimum and maximum of the red, green and blue color intensities. In the loop block, lines 157 to 160 read the red, green, and blue color intensities. Lines 162 to 167 set the minimum when it is signaled that it is time to do so. Recall that only when the white button is clicked, this signal variable is set. Similarly, line 168 to 173 set the maximum when the black button is clicked. Lines 176 to 178 translate the red, green and blue intensity values into the corresponding color values. Lines 180 to 193 print the values to serial port. Lines 196 to 197 set the intensity values to the plotter layers. Lines 199 to 202 set the color of the R, G, and B LED layers according to the inverse of the color values. Darkness of the color is sort of indicated by the inverse of the color value. Lines 205 to 206 set the background color of the color LCD layer to the actual color detected. Lines 209 to 212 set the red, green, blue color values to the 7-segment layers. That is it. Let's see the demo. To calibrate, shine white to the color sensor, then click the white button. Shine black to the color sensor, then click the black button. This finishes the calibration. Have fun with DumbDisplay. May God bless you.